NASA releasing a slew of new full-color infrared images demonstrating what the largest space telescope ever built, known as the James Webb, is capable of. And you are looking at some of the deepest views of space ever captured.
These first early release observations really give us a glimpse into how JWST will transform our understanding of the universe. JWST was designed to peer back to the edge of time to see the first galaxies forming.
In the previous episodes of our James Webb Space Telescope series, you have seen the amazing discoveries that James Webb Space Telescope has made possible by the data it has sent back to us. The scientists are considering every bit of that a game changer because we have never seen these things before. Today's video will analyze the first 5 images of James Webb Space Telescope released by NASA on 12 July 2022 and how impactful they can be in our lives. These images are the one most profound look into the universe 4.6 billion light-years away. 2. The signs of carbon dioxide in the atmosphere of an exoplanet. 3. The stunning Southern Ring Nebula, a dying star 2,600 light-years away. 4. Stephan's Quintet is the largest image of James Webb Space Telescope, also known as the cosmic dance of galaxies. 5. The last and perhaps the most phenomenal of all are the new details of the Carina Nebula. Launched on the Christmas of 2021, James Webb Space Telescope has opened a new world of knowledge and information after completing its commission phase of 6 months, in which it reached and settled down in its orbit. The next 20 years of James Webb Space Telescope are perhaps the most momentous time in whole human history since we started gazing at the stars, because the images in this video we will discuss are taken in only first 5 days of its functioning. So it is fascinating to think about all the things James Webb Space Telescope can do, as we probably don't even know what we have to expect. Now let's individually decode each image released by NASA. But before that, do something to quench your thirst for science and knowledge by subscribing to the channel. Our industrious team is working hard to make videos on topics that are deeply associated with curious minds. So give a thumbs up to that. According to NASA's own explanation of this image shows the galaxy cluster SMAC is at 723, which appeared 4.6 billion years ago, with many more galaxies in front of and behind the cluster. This cluster will reveal much more as researchers begin digging into Webb's data. This field was imaged by Webb's mid-infrared instrument, which observes mid-infrared light. Webb's near-infrared camera has brought distant galaxies into sharp focus. They have tiny, faint structures that have never been seen before, including star clusters and diffuse features. Light from these galaxies took billions of years to reach us. We are looking back in time to within a billion years after the Big Bang when viewing the youngest galaxies in this field. The light was stretched by the expansion of the universe to infrared wavelengths that Webb was designed to observe. Researchers will soon begin to learn more about the galaxy's masses, ages, histories, and compositions. Other features include the prominent arcs in this field. The powerful gravitational field of a galaxy cluster can bend the light rays from more distant galaxies behind it, just as a magnifying glass bends and warps images. Stars are also captured with prominent diffraction spikes, as they appear brighter at shorter wavelengths. Webb's mid-infrared instrument image also offers a kaleidoscope of colors and highlights where the dust is, a major ingredient for star formation and ultimately life itself. Blue galaxies contain stars, but very little dust. The red objects in this field are enshrouded in thick layers of dust. Green galaxies are populated with hydrocarbons and other chemical compounds. Researchers will be able to use data like these to understand how galaxies form, grow, and merge with each other, and in some cases, why they stop forming stars altogether. WASP-39b is a hot gas giant planet. The mass of this planet is almost 1/4 of Jupiter, almost equal to Saturn, and has a diameter of 1.3 times greater than Jupiter. The temperature of this planet is, on average, 900 degrees Celsius. Again, NASA's team of researchers is having following narratives about these pictures. The research team used Webb's near-infrared spectrograph for its observations of WASP 39b. In the resulting spectrum of the exoplanet's atmosphere, a small hill between 4.1 and 4.6 microns presents the first clear, detailed evidence of carbon dioxide ever detected in a planet outside the solar system. As soon as the data appeared on my screen, the hopping carbon dioxide feature grabbed me, said Zafar Rustamkulov, a graduate student at Johns Hopkins University and member of the James Webb Space Telescope Transiting Exoplanet Community Early Release Science Team, which undertook this investigation. It was a special moment, crossing an important threshold in exoplanet sciences. Before, no observatory has ever measured such subtle differences in brightness of so many individual colors across the 3 to 5.5 micron range in an exoplanet transmission spectrum. Access to this part of the spectrum is crucial for measuring the abundances of gases like water and methane, as well as carbon dioxide, which is thought to exist in many different types of exoplanets. Detecting such a clear signal of carbon dioxide on WASP 39b bodes well for the detection of atmospheres on smaller, terrestrial-sized planets, said Nathalie Batalha of the University of California at Santa Cruz, who leads the team. The dimmer star at the center of this scene has been sending out rings of gas and dust for thousands of years in all directions, and NASA's James Webb Space Telescope has revealed for the first time that this star is cloaked in dust. 2 cameras aboard Webb captured the latest image of this planetary nebula, cataloged as NGC 3132 and known informally as the Southern Ring Nebula. It is approximately 2,500 light-years away. The edge on images of the Southern Nebula doesn't show many details, but a 3-dimensional side-on angle of the image is just wonderful. Stephan's Quintet, a visual grouping of 5 galaxies, is best known for being prominently featured in the holiday classic film, It's a Wonderful Life. Today, NASA's James Webb Space Telescope reveals Stephan's Quintet in a new light. This enormous mosaic is Webb's largest image to date, covering about 1/5 of the Moon's diameter. It contains over 150 million pixels and is constructed from almost 1,000 separate image files. The information from Webb provides new insights into how galactic interactions may have driven galaxy evolution in the early universe. With its powerful infrared vision and extremely high spatial resolution, Webb shows never-before-seen details in this galaxy group. Sparkling clusters of millions of young stars and starburst regions of fresh star birth grace the image. Sweeping tails of gas, dust, and stars are being pulled from several of the galaxies due to gravitational interactions. Most dramatically, Webb captures huge shock waves as one of the galaxies, NGC 7318b, smashes through the cluster. Together, the 5 galaxies of Stephan's Quintet are also known as the Hickson Compact Group 92. Although called a quintet, only 4 of the galaxies are truly close together and caught up in a cosmic dance. The 5th and leftmost galaxy, called NGC 7320, is well in the foreground compared with the other 4. NGC 7320 resides 40 million light-years from Earth, while the other 4 galaxies, NGC 7317, NGC 7318A, NGC 7318b, and NGC 7319, are about 290 million light-years away. This is still fairly close in cosmic terms compared with more distant galaxies billions of light-years away. Studying such relatively nearby galaxies like these helps scientists better understand structures seen in a much more distant universe. This landscape of mountains and valleys, speckled with glittering stars, is actually the edge of a nearby, young star-forming region called NGC 3324 in the Carina Nebula. Captured in infrared light by NASA's new James Webb Space Telescope, this image reveals for the first time previously invisible areas of star birth. Webb reveals emerging stellar nurseries and individual stars that are entirely hidden in visible light pictures. Because of Webb's sensitivity to infrared light, it can peer through cosmic dust to see these objects. Protostellar jets, which emerge clearly in this image, shoot out from some of these young stars. The youngest sources appear as red dots in the dark, dusty region of the cloud. James Webb Space Telescope is taking humanity to new heights that were very difficult or almost impossible to imagine before. All this looks like a science fiction movie after just the first 5 days of the mission. What will be the ending of this movie after 2 years? Stay tuned with us. This is the end of today's video. Please like the video and subscribe to the channel for one of the most detailed videos on the internet on your favorite topics. Also, let us know about your precious feedback in the comment section.